Hello everyone, welcome to a new section, and this section is going to be pretty small relatively, and in this section I'm going to talk about only Spark partitions because we have talked about so many things over the entire course so far. We have talked about input partition, shuffle partition. I have not talked about output partition yet, but in this particular section I'm going to consolidate all of them, and also I'll do some experimentation. This is going to be the agenda. I'll start with input partitions. You already know what input partitions are, and then we'll see whether we can experiment with input partitions, whether we can change the input partitions. The reason we have to talk about partitions because the number of tasks in Spark would be equal to the number of partitions that you have. So can we change that? By default, the input partition size is 128 MB. Can we configure that or not? Then I'll talk about shuffle partitions. I'll just give you a recap. I'm not going to do any hands-on as such because we have talked about shuffle partitions in the last section. Then I'll talk about output partitions, which I have not discussed yet, and how you can control output partitions using APIs or transformations like repartition, coalesce, partition by. Then we'll see the transformations that change partitions, and finally I'll conclude this section with output mode. Before talking about input partitions, let's try to understand why I'm giving so much of emphasis on partitions. The reason is because the number of tasks that you see in a Spark application is dependent on the number of partitions. And there are various type of partitions like input partitions, shuffle partitions, and output partitions. Let's say you have 100 partitions, then Spark would create 100 tasks. If you have, let's say, 10 partitions, then Spark would create only 10 tasks, irrespective of the number of CPUs or number of cores that you have in your cluster. So that's why handling partitions become very important and critical for your Spark application, because the number of tasks would be dependent on the number of partitions. There are three places that we see or recognize Spark partitions. Those are input partitions, when you are reading a file or maybe database or data warehouse to a data frame, then during shuffle, and then during output write, whether you are writing it in a file or in a database or in a data warehouse systems or into streams. So that's why I'll be talking about all these partitions one by one. So first is the input partition, and as you already know, we might have an input file, but it can be a relational and non-relational database also. It can be data warehousing systems also, or it can be streaming ingestion technologies like Kafka or Kinesis. So when I say input file, I mean it can be any source. I'm showing you a file. So what happens is that whenever you read that input file, the input file is divided into partitions. This is true for database sources and streaming sources also. In case of file, the number of partitions are created using the formula total file size divided by 128 MB. So based on that, the input partitions are created. So these are input partitions. And if you use a database, then the number of partitions would be depending on the database, which you'll see in RDBMS or NoSQL sources. Same would be the case for streaming ingestion also, which we'll see in the Spark streaming section. But these are input partitions. And then what happens? The number of tasks would be dependent on the number of input partitions. So in this case, as we have 4 partitions, that's why 4 tasks have been created. So if the number of partitions are 40, then 40 tasks would be created. And if you have, let's say, 4 CPUs only, the 40 tasks would run in batches of 4, and it will iterate over 10 times to process all the input partitions. And after that, if there is a shuffle transformation or a shuffle process involved, then it will go to the shuffle writer, and shuffle writer would write it to the temp files, and then it will be read by the shuffle reader, and then the tasks would actually read the data from the shuffle partitions, and then it will go to output file, and then it would be written to individual output file partitions. So that's why you have seen multiple output files. In cases, we have seen number of output files to be 194, and we have seen number of output files to be 200 also, depending on the shuffle partition. So if you do not have any shuffle partition, then the in-between number of partitions might or might not change depending on the transformation that you are using. But in case of input partition, the single partition size would be equivalent to the HDFS block size, which is 128 MB. And the number of input partitions would be equal to this total size of the file divided by 128 MB. So total size of the file in MB, in megabytes, and then you'll have to divide it by 128 MB, and that's how we can get the input number of partitions. But this is the default, and the question is there a way that we can change this behavior of Spark wherein the partition size is something other than 128 MB? Why we want to change partition size? Because you might already know by now that the number of partitions or the number of input partitions would be dependent on the partition size. So is there a way to change it? So by changing a partition size, you can change the number of input partitions also, which affects this input partition, whether you are reading it from file or databases or streaming sources. So is there a way to change it? The answer is yes. We can use this configuration parameter, that is spark.files.maxPartitionBytes. By default, it is 128 MB, but we can change it using spark.conf.set API or action. We have already used this particular API in changing the shuffle partitions, but you can do the same to change the input partition size using spark.files.maxPartitionBytes. And after that, we can look at the number of input partitions using the data frame name .rdd.getNumPartitions. So let's go ahead and do some experimentation on the input partition. For the hands-on exercises in this particular section, and maybe for the next sections, I'll be using this data, I'll be using this flight data. And there are three CSV files, flight data _1, _2, and _6. For your practice, you'll get all the files, the size of which would be much higher. Anyway, for these three files, the total size is 6.28 GB, and that boils down to approximately 50 partitions. So 49.06, which is 50, it can be 49 or 50 also. So let me go ahead and read the files and experiment with maxPartitionBytes. Before this code, I have this particular code which is converting the CSV files to Parquet file, and it will convert to a single Parquet file because I've used something called coalesce, and I'll talk about it shortly. Anyway, let's do and look at the input partitions first. So I'll create a data frame which is data frame _flight. Let's read it from the folder, and the name of the folder is flight _data _CSV. Okay, before that, let's print the parameter, and we'll have to use spark.conf.get, and the parameter is spark files max partition bytes, which is in bytes, by the way. And based on this, let's try to find out the number of partitions of the input data frame, and this would be the input partitions, right? So it errored out, and let's look at the error. You can see that the exit code is 1, which is an error. So there's an py4j Java error. So it says SQL conf not found. The SQL config spark.files.maxPartitionBytes cannot be found. Sorry, my bad. The parameter name is spark.sql.files.maxPartitionBytes. And let's execute it again. So this is the number of bytes, and if you convert it to megabytes, it will be 128 MB. Now let's look at the number of input partitions. What would be the number of input partitions? Which is 48, right? So that's what we had calculated. It is approximately 48. So let's go ahead and make some changes. But before that, let's do some processing and see whether we get any performance improvement when I use lesser number of partitions by increasing the size of maxPartitionBytes. But for that, I'll be using the Parquet file rather than CSV, because as I told you earlier also that you should always use Parquet file format, either Parquet or Abro, mostly Parquet, because it gives you much better performance than CSV. So let's go ahead and use Parquet. And just for confirmation, let's look at the number of partitions again. Now in case of Parquet, the number of partitions would be less, right? So what is happening here is that the number of partitions is only 12. Why that is the case? So when I created this particular Parquet folder or Parquet file, I had only used two files, 1 and 6, sorry, 2 and 6, not 1. So the size of the second file, flight data underscore 2, is 2 GB, and the sixth one is 2.07 GB. So approximately 4.2 GB. And if you see the Parquet file, the size is only 1.5 GB. So from 4 GB to 1.5 GB. So that's how Spark reduced the size of the file itself, and by doing so, we have reduced the number of partitions and we have reduced the requirement of task also. By default, Spark does snappy compression, and using snappy compression itself, we were able to achieve more than 3 times of compression. So that's why the partition size is 12. Now what am I going to do is that I will do some transformation, maybe a select transformation, to select these many columns, and also I'll use a filter transformation wherein I want to find out only for the passengers whose country is India. Let's put it in a data frame, and the name of the data frame is df1. Let's look at the number of partitions in this case. Input 1 partition, which was read from file, and then input 2 partition, which was after some transformation. So the input partition is 12, and after execution also it is 12, so nothing changed. But now what am I going to do is that I'll change this parameter, right? So I will use spark.conf.set to change the value of this particular parameter, and it has to be in bytes, remember that. And let me make it to 512 megabytes instead of 128, and this is the amount of bytes. Now let's look at the number of partitions. Okay, so the input partitions got reduced to 6 instead of 12. And now what will I do? Let's look at some performance improvement, whether we get any performance improvement or not. And first I will use the same maxPartitionBytes, which is 128 MB, reading the Parquet files. This is the input and output partitions. And then let's do a df1.write.format. Format would also be Parquet, and save in a test file, right? So that's what I want to do. Let's look at the execution time, and in this case the input partition size is 128 MB. Okay, the execution got complete, and I'm using 6 executors this time. Let's look at the history server, and this is the name of the application, Input Partitions maxPartitionBytes. This is the latest one actually, and let's look at it. So it took 2.7 seconds. Obviously the load used 1 task and the save used 12 tasks. So 0.07 seconds for the first job and 2 seconds for the second job. Right. So now what will I do is that I'll change the partition size to 512 MB. Sorry, I'll have to delete the file, otherwise it is saying path already exists. We'll change it in the file mode. So anyway, let me go ahead and delete and execute it again. Okay, the number of input partitions is 6. And as I told you that I'm using 6 executors this time, let's look at the execution time. And this is the latest one. Scroll down, but it is also taking almost similar time. Even with 6 tasks, the execution time is 2 seconds only, and this is 1.5 GB of file. Now let's do the same with CSV, just to continue with the experimentation. And if you do it with CSV, then what would happen is the size of the file would be at least a little more. For the first run, I'll not change the size of maxPartitionBytes, or I'll not change the partition size. So for CSV, the input partition size is 128 MB, and the number of partitions are 48, and the execution time was quite higher. So if you see, this is with CSV, the execution time is 23 seconds. And if I go inside of it, the load itself took 12 seconds and the write took 8 seconds with 128 MB of partition size. I'll execute the same by changing the size of the partition, and I have deleted the file also. Let's execute it again. So the number of input partitions got reduced by 4 times because I increased the size by 4 times. So 128 MB into 4 is 512 MB. That's why the input partitions have reduced from 48 to 12. Last time it did not happen because I had only 6 executors, so it did not get reduced to 3. All the 6 executors were used. And let's look at the execution time. It is similar, 23 seconds itself. And I think the load took 12 seconds. The save took 7 seconds. So it did not make much difference with the CSV file. And there was not much difference in Parquet file also. So it makes sense to keep the input partitions to 128 MB. At least for this use case, it did not provide any substantial improvement. And in fact, for most of the workloads, that would be the case. You'll not be able to see too much of improvement if you change the input partition size. So if the situation is as such that you are creating, or Spark is creating thousands of tasks, then you can change the input partition size. But apart from that, I don't think there would be any performance gain or improvement if you change the input partition size using maxPartitionBytes. And by the way, if you're the kind of person who learns best by doing, building real world data engineering pipelines and seeing how these concepts play out in actual projects, I have linked one of my go-to resources in the description, Project Pro. Their Spark projects walk you through scenarios where tuning shuffle partitions isn't just theory, it's the difference between success and a job failure. I have put the link in my description. So we have completed the experimentation with input partition.